Hello everyone. Today we're going to be looking at an intro to graphing quadratics. Remember that the standard form of a quadratic is ax squared plus bx plus c. And this right here, this is the standard form. And another form we're going to be looking at in a couple videos is f of x is equal to a times x minus h in parentheses squared plus k. And this is called my vertex form. Those are our main two forms that we're going to be looking at this unit. But let's just get into what does a parabola look like, or what even is a parabola. A parabola is the graph of a quadratic. A quadratic function. So if you'll notice, here's an example of a parabola. It's kind of like a U-shaped graph. So some things that are similar are these two arrows are pointing to our x-intercepts. We've talked about x-intercepts before. So that's an x, sorry about the handwriting, an x-intercept. Remember that these are also called roots, solutions, and zeros. Those are all synonyms for x-intercepts. You also notice what else do they have in common? This down here is my y-intercept, and that's where it crosses the y-axis. A couple of the new things is that this red arrow right here is pointing to my vertex. And that's either going to be the lowest or the highest point of a parabola. And then pointing to this green arrow, that's called my axis of symmetry. And we are going to abbreviate that with AOS for short. And the axis of symmetry goes through the vertex, dividing the parabola into two equal parts. It's the whole idea of symmetry. All right? And notice, what type of line is it? It's a vertical line. So if it's a vertical line, remember that all vertical lines are x equals a number. So those are our key parts that we're going to be looking at to start. The other two concepts is concave up or concave down. Concave up simply means that your parabola is opening up. Concave down means that you're opening down. Concave up because the opening is at the top like a cup. So concave up, cup. Concave down is opening down like a frown. So concave down, frown. So if your parabola opens up, your vertex is the minimum of the graph. It's the lowest point. If your parabola is concave down, then your vertex is going to be the maximum. It's going to be the highest point of the parabola. So, what does this all look like? Well, their parent function, or our starting place, the parent function is f of x is equal to x squared. So what I want to do is I want to think of an xy table, and I want to plot some points. I want to plug in -2, -1, 1, and 2. So when I plug -2 in, -2 squared, that's going to give me +4. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So if I come over to this graph and I plot those points, you can start to see some symmetry happening. So after I plot all these, okay, you can see some symmetry happening. Your AOS is your y-axis, and your y-axis is x equals 0. That's the equation of this y-axis here. So let me plot that y-axis. Your vertex, Remember, your axis of symmetry goes through your vertex, so that vertex coordinate is 0, 0. Your x-intercepts, once again, 0, 0. Your y-intercept is 0, 0. So your parent function is just the basic parabola, your basic quadratic. What does it look like? Am I dealing with a maximum or a minimum? I'm dealing with a min, which means that we're going to be concave up. So if I connect these dots here, I'm going to plot another point. I'm going to plug in 3 as well. If I plug in 3, I get out 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because of symmetry, I know it's going to be over here as well. So I connect all the dots into a nice smooth curve. I get my parent function parabola. So remember, domain, that's asking, okay, what are my inputs here? So domain, think your inputs. What can I plug in for x? Well, I don't have any restrictions on what I can plug in for x. So my domain is any number between negative infinity and infinity. My range is my outputs, or what I can get out in my y values. Well, notice, there is no range in the third and the fourth quadrant, below the x-axis. The smallest number you can get out is 0. So my range, y, has to be anything bigger than or equal to 0. I can get anything above the x-axis. I can get any outputs I want. Okay? So I will tell you, your domain is always going to be between negative infinity and infinity for a parabola. Your range is going to depend on, so it depends on the vertex location. So that's our parent function, x squared. That's what it looks like, and those are its key characteristics. But not everything is always just going to be a parent function. So if I look at this problem here, I gave you a graph to the left, and I want to identify the key characteristics. Well, the axis of symmetry, you can notice that your axis of symmetry is right here. That's your AOS, and that vertical line is x equals 1, 2, 3, 4. X equals 4, which means that your x-coordinate of your vertex is going to be 4, and then that minimum value, what happens when I plug in 4, I get out negative 1. So that's my vertex. My x-intercepts, where it crosses the x-axis, there's 2 of them. So I get 3, 0, and I have 5, 0. My y-intercept, where does it cross the y-axis? So if I look at the y-axis right here, it crosses it at 0, 15. Am I dealing with a maximum or a minimum? I have a minimum because it's concave up. My domain is always negative infinity to infinity. And my range is any value bigger than or equal to negative 1. So make sure you get that written down. Alrighty, and then we also want to graph it. So in order to graph, for right now, we don't have all the algebra skills and the formulas that we need, but we can create a table. If I create a table, I'm going to plug in negative 2, negative 1, 0, 1, and 2. That's usually always my starting place. And then once I start to find the symmetry, I can figure out other coordinates to place. So if I'm plugging in negative 2, I'm actually going to plug that into my function and see what I get out for y. So I don't know what my y value is, but I do know, I'm going to make my smaller, I do know that my x-coordinate is going to be negative 2, because that's what I'm plugging in. So negative 2, right here, negative 2 squared is 4. 4 times negative 2 is negative 8. This 4 times negative 2 is negative 8. So negative 8 plus negative 8 is negative 16. So the ordered pair is negative 2, negative 16. Well, that's not even on my graph, so that point's not going to help me. But Let's try -1. If I try -1, y is going to be -2 times -1 squared plus 4 times -1. If I simplify that expression, my output is going to be -6. So -1, -6. That point is on my graph. So let's plug in 0. Let's see, what do we get out for 0? When I plug in 0, I have, I gotta make this a little smaller. Y is equal to -2 times 0 squared plus 4 times 0. Well, everything's getting multiplied by 0, so my output is just going to be 0. So it turns out that 0, 0 is going to be a point as well. If I plug in 1, y is going to be -2 times 1 squared plus 4 times 1. If I simplify that, I get 2. So 1 comma 2 is going to be a point. And then if I plug in 2, just using my table, let's see if this is going to work. There we go. And y equals -2 times 2 squared plus 4 times 2. When I simplify that, I get 0. So 2 comma 0 is going to be a point. So I see that I have symmetry happening. And because I have symmetry, that means that this is going to be my axis of symmetry right here. I have symmetry, so I have another point over here to match this, which I already found. And then that's 5 points, so I can then connect the dots. That with this. I have that parabola. It's opening downward this time. So my axis of symmetry was x equals, looks like 1. My vertex is 1 comma 2. My x-intercepts were 0, 0, and 2, 0. My y-intercept was 0, 0. I had a maximum this time because it was concave down. My domain is always -infinity to infinity. And my range, let me get a different color for this one, because my range is anything smaller than that maximum value. The maximum value, remember that's my max, the maximum value was 2. So y has to be less than or equal to +2. Okay? So that is our intro to Unit 7. We'll take care of that later. Make sure you get all that written down. That's going to be really helpful as we move on to figuring out the algebra ways to find all these key characteristics. As always, if you have any questions, please write it down. Let me know. As always, please be safe, be good, do some good, and I will see you when I see you.